This video will look at surds. So what are surds? So surds, these are numbers that cannot be simplified such that we remove the root, it can be the cube root, etc. So examples of surds. We have root of 2, root of 3 plus 4, root of 11. These are surds. We cannot simplify these further to remove this root, because inside here we do not have perfect squares, so we cannot remove that root. So in these surds cannot be written as a fraction as well. The reason they can't be written as a fraction is because they give a non-repeating uh, non-terminating decimal number. So for example, the root of 2 gives us a number which is 1.4142135 and it continues to go on and go on like that. It is non-repeating and it is non-terminating, so we can't write this as a fraction. But now we can be able to manipulate these surds with some rules or principles. So we have the first one that okay, let me erase this part. So we have the first one to be, if we have root of a plus root of a multiplied by b. So if I have two numbers, two integers that are multiplying, a and b, I can separate these inside to have a alone and multiplied by b. So this can also be written as a then root of b, like this. So this is the first property that is very cardinal in the study of surds. Then the other one is that the root of a divided by another number b, then I can separate these to say it is a over root of b, like this. And the other one that follows is, if I have root of a multiplying by root of a, so this is equal to a. It is equal to a because the root here a, I square this, that square cancels out with the 2 and I just remain with a. So these are the three properties that we will use in order to work around surds. Now let us answer a few questions. So we have these questions here that say simplify the following. Simplify these. So a, how are we going to answer a? So we have a there saying root of 28. So root of 28. So your aim is to try and multiply here, to break down this root of 28 into two numbers that will be multiplying, where you have one perfect square and another which is not a perfect square. So I can break down this 28 into numbers. So I have 4 multiplied by 7. So 4 is the perfect word square, because when I find that the root there, I will get 2 for 4. Then 7 is not a perfect square. So from there, what I do is I can separate that to say 4 root of 7, like that. Then this will just give me the root of 4 is 2, then root of 7. So I have simplified that one. Now I do the same for the next one. I have b to have 72, that's 72 divided by 2. So inside there, if I multiply 36 by 2, so 36 is the perfect versus in that case, then I have divided by 2. Then this is going to give me root of 36 multiplied by 2 divided by 2. The root of 36 is 6, so you have 6. This will be equal to 6 root of 2 divided by 2. And 2 can divide into 6, such that you have 3 equal to root of 2. So you've simplified that one as well. Now let us work out the last one. So the last one is 5 multiplied by the root of 6 minus 5 root of 6 minus 2 root of 24 plus root of 2294. So when you see such a question and inside here you see that there's already an existing root inside which is not a perfect square like this one here, so meaning even these ones would have to be in the form where they have a root of 6. So now how are you going to do that? You just say root of 6 minus 2, then when we multiply there, when we multiply 4 by 6 we get 24, so that will be 4 multiplied by root of 6 plus, so in the other one it's 49. When we multiply 49 by 6 we will get 294. So that is going to give us 5 root of 6 minus, so this root of 4 will just be 2, so 2 multiplied by 2 we get 4, then root of 6 plus the root of 49 here is going to be 7 multiplied by 6, and you will have, so you can add, these have all common versus root, so meaning you can add the numbers in front, 5 minus 4 plus 7, and that is going to give you 8, and then you keep that root there, that will be root of 6. So that is your final answer. Let us look at more questions. So we have these questions here tell us to evaluate those. So how do we do that? So we have the first one which says 2 root of 7 multiplied by 3 root of 7. So in this one what we do is, we said since they have the same root we can multiply the 2 there. So we will multiply those 2. We have 3 by 2, 2 by 3. Then we have 7 multiply the root of 7 multiplying by the root of 7. So that is the same as saying root of 7 squared. And here we know that this goes with that. And then you have 2 by 3 by 7. And this gives you 42. So that is your answer there. Now let's do the following question. So this question needed to have a squared here. So that, how are we going to do that? So that means that 5 root of 5 plus root of 2 is multiplying by itself. That is root of 5 plus root of 2. So we do that. How do we do that? So we will multiply, say 5 root of 5 multiplied by root of 5 plus root of 2, then plus root of 2 multiplied by root of 5 plus square root of 2. So here when you have the square root of 5 multiplied by the square root of 5, that will be square root of 5 squared, like this, plus this square root of 5 multiplied by square root of 2 will just be square root of 2 then multiplied by square root of 5. Since they are not the same numbers, so we cannot write like the same way we wrote in the first part. When we do this, square root of 2 multiplied by square root of 5, it will still be square root of 2 and square root of 5. Then the last part will be just square root of 2 squared, like that. So what do we get in the first one? Here we get, so the square cancel out, then we get 5, and there we get, so that is 1 plus 1, then we keep those roots, that will be 2 root of 2 root of 5, then the last one there you get 2, then you can add 2 plus the 5 there, then you get 7, that will be 7 plus 2 root of 2 root of 5 as your final answer. Now let us do the last question. So for the last question, we follow the same procedure as we are just from doing this one. So how do we do that? So we have, you say 2 root of 3 to be out, then you multiply it by 2 root of 3 plus 2 plus 2 root of 5, like that. Then the second part is negative root of square root of 5, then 2 square root of 3 plus 2 square root of 5. Then this, when multiplying now, we have, so when we multiply 2 by 2, that will give us 4. So that will be 4. Then this, they have a square, so the square will cancel, and we will have 3 remain. So that will be by 3. Then we multiply the second part, 2 by 2, we get 4. So that will be 4. Then these are different, so we just bring them there, 3 and root of 5. Okay, for the second one, we multiply same way, negative the negative square root of 5 multiplied by 2 square root of 3. I have negative 2 square root of 3 square root of 5. Then for the last one, that will be negative 2, the 5 by 5, the root of 5 will cancel, and then I'll just remain with 5 there. So this in the first part here gives me 12, since 4 by 3 is 12. Then here I can subtract, and we will have 2 root of 3 root of 5 remain. Then in the last one there, I will get negative 10. Then I can group here, I can add, so I can add 12 and negative 10 there. So that gives me 2. Then 2, so this I can put it under 1 square root, and that will be 3 by 5, that's 15. So this is my final answer. If I want, I can even factor out a 2, and then I have 1 plus root of 15. So that is how I get my answer.